The sum rule is one of the most important rules of probability. Let's see what this is all about. So consider again the background information I and some logical sentence that may be of interest to you, which we're gonna call A. And now take two logical sentences, B1 and B2, which have the following properties. First of all, one of them must be true. So the probability of B1 or B2 being true is 1. The second property is that only one of them can be true. So the probability of B1 and B2 being true at the same time is 0. The sum rule has two forms. The first, it states that the probability of A can be decomposed as the probability of A and B1 plus the probability of A and B2. And of course this is kind of obvious because AB1 is this area right here and AB2 is this area right here. So it basically says that the area of A decomposes to the area of AB1 and the area of AB2. But you can take it a step further by applying the product rule on each one of these terms. So the first one is simply the probability of A given B1 times the probability of B1. And the second term is the probability of A given B2 times the probability of B2. Both forms of the product rule are extremely useful and you should remember them, you should memorize them. Let's now apply the sum rule to a simple example. We have already found the probability of drawing a blue ball in the first draw, the probability of drawing a red ball in the first draw. We also found the probability of drawing a red ball right after a blue ball, and we can easily also find the probability of drawing a red ball right after a red ball in the first draw. And now we're going to find the probability of drawing a red ball at the second draw. So the way we're going to decompose this is using the sum rule, and here's how you do it. The probability of drawing a red ball in the second draw is the same as the probability of drawing a red ball right after a blue ball plus the probability of drawing a red ball right after a red ball. And of course, these probabilities can be further decomposed into the probability of a red ball condition that we had first blue ball times the probability of a blue ball in the first draw, and the second one becomes the probability of drawing a red ball in the second draw, condition on having drawn a red ball in the first draw times the probability of a red ball in the first draw. So now all you have to do is plug in these numbers. So the first one is 2/3 times 2/5, and then you have 5/9 times 3/5, and if you do the computations you're gonna find a specific number. Now let's derive a generalization of the sum rule that is quite obvious. Now instead of just two events, we're going to consider three events that decompose the space B1, B2, and B3, and these have to have the following properties. One of them must be true, and no two of them can be true simultaneously. The probability of A given I can be decomposed as follows. Probability of A and B1 being true at the same time plus the probability of A and B2 being true at the same time plus the probability of A and B3 being true at the same time. And of course these probabilities correspond to these areas respectively. And of course, if you apply the product rule to each one of these probabilities, you will get this formula: probability of A given B1 times the probability of B1 plus the probability of A given B2 times the probability of B2, and so on and so forth. Finally, the sum rule can be also written for an arbitrary number of b's. So you can have here b1, b2, to bk. As soon as these b's satisfy the following properties, one of them must be true. So the probability of b1 or b2 or bk must be 1, and no two of them can be true at the same time. So the probability of bi and bj being true at the same time is 0. Then what we can do is we can write the probability of A given I as the probability of A and bi being true, sum over all the possible bi's, k of those. And of course, if we apply the product rule for each one of the terms, we're going to get an expression that looks like this: the sum over I of the probabilities of A given bi times the probability of bi, like this. Now this is the most general form of the sum rule, and you absolutely need to remember it because we're going to use it about 100 times in this course.